So let's talk about the ECG. The ECG, electrocardiogram. So, firstly, the study of the electrical conductivity is what we call electrocardiograph. Study of electrical conductivity of the heart. Therefore, when we study this electrical conductivity, we are going to record the information on the electrocardiogram. So, electrocardiogram, that's why we record the information of electrical conductivity of action potential or the action potential of the heart or action potential of the heart. The cardiogram, let me draw the cardiogram. So these are our axes. Here we're going to record the voltage in millivolts. Here we're going to record the time taken in seconds. Then the action potential for the heart. The heart is myogenic, meaning the heart creates its own action potential. And this is due to the unstable voltage in the SA node. So the action potential starts, this is the isoelectric point. Then as it goes, we have the P wave. This is P wave. Then this upward deflection is just a positive deflection. The electrocardiogram is measured, or the information is brought by the leads, the electrocardiogram leads, which we are going to place on the board. So the P wave is just the atrial depolarization, the depolarization of the atrium. So this depolarization will create a positive deflection. The amplitude for this one is around 0.25 millimeters. The amplitude is amplitude, and also the time is around 0.12. When it is less than 0.12, there is an abnormality with the myocardium. Sometimes there is hypertrophy of the heart, which means the heart muscles, the heart is larger, the heart muscles of the heart are larger, or the hyperkalemia, which is the increase in high levels of potassium. Hyperkalemia, what will happen is it may cause a small deflection or absence of a deflection in the atrial depolarization, P wave here. So from P wave, we are going to have a Q wave here. Then from Q wave, there is upward deflection, and then the deflection returns back again, then to moves. Now we are going to T wave. So this is now Q R S, and at this QRS is now ventricular depolarization. So P wave, atrial depolarization, QRS wave is ventricular depolarization. So this is the period of the movement of the action potential to the AV node, where there is a delay of 0.02 seconds. So at this period, there is the beginning of the ventricular depolarization, but it starts with a negative deflection to Q. I will explain later what this deflection means in the next video. So for this one, there is ventricular depolarization. So for atrial depolarization, systolic happened here, and ventricular depolarization, when the ventricles are depolarization, contraction of the ventricles. Okay, then from here S and going to T, what will happen for the T wave? There is ventricular repolarization. Ventricular repolarization. The heart is now propelling back to its normal. The action potential is returning back to its normal at this wave, which is T wave. A change in the shape of the T wave, it simplifies the abnormality, sometimes due to hyperkalemia, due to damage of other muscles of the heart. So this is the basic information for the electrocardiogram. And more information, we are going to explore what this means, the upward deflection, how it occurs, the leads which are used, the names of the leads. Thank you.